These are the quadratic formula notes with exact answers. When you have exact answers, you want to leave your answers in fraction form, not in decimal form. So if you go ahead and divide at the end and you get a decimal answer, then you need to reduce the fraction or leave it as a fraction and not use the decimal. If you get a whole number answer, then of course you leave it a whole number. Then you would leave your answers in square root form, not decimal form. So for example, this 2 plus square root of 51 divided by 3 does not, square root of 51 is 51's a prime number. It doesn't factor down. There's nothing you can bring out of it. This square root does not break down. Okay, so I would want you to leave your answers like this instead of putting it in the calculator and getting these decimal answers, and I'll show you how to do that. All right, so here's the quadratic formula at the top. Okay, the first example, 2m squared minus 7m minus 3 equals 0. The first thing I would do, just like with the regular quadratic formula problems, is I would identify a, b, and c. A would be your first number, if this is in descending order. B would be your middle number, and C would be your last number. Since this is in descending order, I can do it that way. Okay, and then plug them into the appropriate spots. Okay, so your formula says x equals negative b, so a negative 7 would really be a positive 7, plus or minus the square root of b squared, so negative 7 squared, minus 4 times a, which is 2, times c, which is negative 3, all over 2a, and a is 2. So just like before, I would just start PEMDASing the square root in here. Okay, so we'll still have 7 plus or minus the square root. Negative 7 squared, a negative times a negative is a positive 49. Okay, and then negative 4 times 2 times negative 3 would give us a positive 24. And then 2 times 2 here in the bottom is 4. Okay, so you will end up with 7 plus or minus, if I add 49 and 24 here under the square root, I would get 73 all over 4. Okay, so last week in the calculator you would take 7 plus square root 73, enter, divide by 4, enter, and that would give you your first answer. And then 7 minus square root 73, enter, divide by 4, enter, and that would give you your second answer, both answers being a decimal. Okay, but this week we are going to take our square root and we are going to see if it factor trees. If it factor trees, we're going to bring anything out of the square root we can. We're going to simplify it and then reduce the fraction from there. 73 is prime, so there's nothing I can break down in this square root. There's no way to simplify this, so I can't do anything. So the exact answers would be m would equal 7 plus square root of 73 over 4, and m would equal 7 minus square root of 73 over 4. Those would be your two answers, and those are exact answers. Those are not rounded, okay? All right, example 2. Again, if your problem's in descending order, I would start by identifying a, b, and c. A would be 9, b would be negative 7, and c would be negative 4. If it's in descending order, a is the first number, b is the middle number, c is the last number. Okay, and then plug them into your formula. So n would equal negative b, so that would be negative from the formula, and then negative 7 from b being negative 7. Again, a negative and a negative. That would really be a plus 7. plus or minus the square root of b squared, so negative 7 squared minus 4 times a, which is 9, times c, which is negative 4, all over 2 times a, which is 9. Okay, again, in your calculator or PEMDASing, I would start under the square root here. So I'd have 7 plus or minus the square root, negative 7 squared, a negative times a negative is a positive 49. Negative 4 times 9 times negative 4 is a positive 144. And then the denominator, 2 times 9, would be 18. Okay, so underneath the square root, we still have 7 plus or minus. Underneath here, 49 plus 144 is 193. And that would all be over 18. Okay? Then you would go and check to see if since we want an exact answer, instead of putting this in the calculator, okay, I would check and see if square root Alright, so the square root of 193 does not reduce. Nothing comes out of 193. So your answer, you could just leave it as n equals 7 plus or minus the square root of 193 all over 18. Or you can break it apart into 7 plus square root of 193 divided by 18 and 7 minus, like we did in the last problem. But this would be the exact answer. It is not rounded. Okay? So this is exact. Alright, example 3. Again, this is in descending order, so I'm going to start by identifying A to be 9, B to be positive 4, and C to be negative 16. And then plug them in. So n would equal negative b, so negative 4, plus or minus the square root of b squared, so 4 squared minus 4 times a, which is 9, times c, which is negative 16, all over 2a, which is 9. Again, with your calculator or PEMDAS, start underneath the square root and simplify that. So negative 4 plus or minus underneath the square root, 4 squared is 16. Negative 4 times 9 times negative 16 is positive 576. All over 2 times 9, which is 18. Again, underneath the square root, okay, keep simplifying that. So we'd have negative 4 plus or minus the square root. If I add 16 and 576, I will get 592 all over 18. Alright, so then you would come back and check and see if square root of 592 simplifies, and it actually does. So square root of 592, since it's even, I know it can go be divided by 2, so 592 divided by 2 is 296. 296 can be factored by 2. 296 divided by 2 is 148. 148 is also even, so I'll divide that by 2. That would give me 74. 74 is even, so that would be 2 and 37. And 37 is prime, so we would be done. If you knew a bigger number to go into 592 or 296 or whatever, you could use those. That would be fine. I just usually go by 2s, 3s, 5s. Okay, then circle your pairs. So 2 is a pair. These two are a pair. Okay, so you use the buddy system, the pairs. If you have a buddy, you get to come outside and play. If you have no buddy, like this 37, you have to stay inside and pout. So a 2 times 2 is coming outside. 2 times 2 is 4. And a 37 is staying on the inside. Okay, so our simplified answer would be negative 4 plus or minus 4 square root of 37 over 18. Now, this is actually not the most beautiful answer. Okay, you would then want to check and see, since we did pull a number out of the square root, you want to check and see if these numbers can reduce and if these numbers can reduce. Okay, if they can reduce, then you want to go ahead and reduce them. So 4 and 18 are both even over here. So 2 goes into 4 2 times. So that would leave me a negative 2. Okay, 2 goes into 18 9 times. 2 also goes into this 4, so it can be simplified. Okay, I can divide all of them by 2, so I can simplify this to negative 2 plus or minus 2 square root of 37 divided by 9. And that would be our most beautiful exact answer with no rounding. Alright, this is a you try, so go ahead and try it on your own and then pause the video. Okay, and then come back and hit play and check your answer. Okay, again, this is in descending order, so I would start by labeling A to be 8, B to be 7, and C to be negative 8, and then plug them in. So N would equal negative B, so that would be negative 7, plus or minus B squared, so 7 squared minus 4 times A, which is 8, times C, which is negative 8, all over 2A, which is 8. Again, I would start by PEMDASing inside this square root or using your calculator, but inside the square root. So I'd have negative 7 plus or minus 7 squared would be 49. Negative 4 times 8 times negative 8 would give me a positive 256. And then 2 times 8 here at the bottom would give me 16. Okay, so underneath the square root, if you showed this step, you would need to add that. So we'd have negative 7 plus or minus the square root of 305, all over 16. Okay, you would need to double check and see if 305 can be factored. It ends with the 5, so I know it can divide by 5. So 305 divided by 5 would leave you with 61. Now 61 is prime. So I can factor it, but I can't pull anything out, so it doesn't matter. So I get to leave my answer as N equals negative 7 plus or minus the square root of 305 divided by 16. Okay, I know this answer doesn't look better to you, but there's no rounding. It's not an approximation. So if you're looking for an exact answer with no approximating, no rounding involved, then this would be the most accurate answer.